welcome everyone. It's great to be here with you on this first day of ER 2023, focused on sustainable food systems. We have a great series of speakers here today joining us from all over the world. We have John Ingram from Oxford University, Marta Tuninetti from Italy, Navin Ramankutty joining us from Canada, Pinki Mondal here from the US, and Simon Jarvis from FareShare Southwest in the UK. So I want to take just a couple moments to introduce our new journal here that's part of the IOP publishing family. This is Environmental Research Food Systems, and I'm serving as the editor-in-chief of this journal. As you may know and be familiar with, IOPP publishes environmental research letters, which is a flagship journal in our field. And there are quite a few sister journals focused on climate, ecology, health, infrastructure, and sustainability, as well as environmental research communications. And so these are all part of the environmental research family. And new for 2023, we also have environmental research food systems and environmental research energy. So I think we're really encompassing the full suite of critical topics relevant for sustainability. So just a few more notes about ERFS. Our goal with this journal is to really cover everything from production to consumption, from local to global, and be a home for rigorous open access science that can promote innovation, inform policy and practice, and foster transformative change for a sustainable and food secure future. So we're really open to a wide array of interdisciplinary topics, recognizing the full suite of expertise and foci necessary to achieve change in food systems. We have a fantastic editorial board helping out with developing the journal. I'll spare you from me reading all these names and potentially mispronouncing anyone, but you can see we have a wide variety of expertise represented here, from land systems, climate and climate change, remote sensing, food policy and economics, food technology, irrigation, and rangeland systems. So these editorial board members also really span the globe, and we're really enthusiastic to have them on board. So I want to share just a couple of our open focus issues. We have our inaugural focus issue, Sustainable Food Systems in a Changing Climate. This is edited by the full editorial board. We're showcasing research that identifies strategies for climate change mitigation and adaptation in food systems. And we're looking at a wide variety of contributions in this area, including reducing emissions or focus on climate risks and resilience. There's also a new focus issue on transformation and stewardship of land systems for sustainability. This focus issue looks at competing visions for the land and how those can be reconciled, and exploring the full solution space for sustainability. And then lastly, we have a focus issue on sustainable irrigation. We're looking at trade-offs inherent in sustainable irrigation transitions, particularly in the global south. And we're looking for new insights on policies, sustainable technologies, and institutions to address the costs and trade-offs associated with sustainable irrigation transitions, and supporting poor and women farmers in particular. So that's it. And with that, I am really pleased to welcome our first speaker of the day. John Ingram is an associate professor and senior research fellow at Somerville College at the University of Oxford. His interests are in conceptual framing of food systems, the interactions among many food systems actors and their varied activities, and the outcomes of their activities for food security, livelihoods, enterprise and business, and the environment. So in addition to leading the Food Systems Transformation Research Group within Oxford's Environmental Change Institute, he also leads the multi-university postgrad interdisciplinary food systems teaching and learning group, as well as the Bean Meals programs. And today, John will be presenting a talk on thinking beyond the can, mainstreaming UK-grown beans in healthy meals, and who has to do what. So thank you, John. Please take it away.
Good, thank you very much indeed. And hello, everybody. So what I'd like to do for the next 20 minutes or so is just share some of the thinking that is behind our interest and our desire to help bring about a transformation in the food system outcomes. And I hope the story builds up in a way which is convincing us all to see who actually has to do what in order to transform, as we say, the food system and the food system outcomes. But let me just start with a question: what do we actually want from our food systems? Very well known concept of food security, 3 major components, which are all well discussed in the literature. Of course, there is also the issue of stability. I always think, is that really a 4th component, or is it really an attribute of the other 3? More recently, the sustainability agenda is writ large, and most recently, again, this importance of agency in the food system, so that those of us who are working in it, and of course depending on it, as in all of us, have the agency to actually get food. But of course, we must remember that the food system actually delivers a whole range of other societal interests. There is the physical food on the left, but then down the right, there's a list of other things that we get from the food system. You could add your own ideas to the list. You could disagree with some of mine. But the fact of the matter is, the food system is such a fundamental aspect of society and so many aspects across society that we really need to understand how to manage the system in a much more nuanced way. First of all, let's just think about the food security. At the top of the slide, there's a very well-known set of words from the FAO. The definition, as they say, it's more, in fact, an aspiration, but nonetheless, it's a really valuable guiding star. And how come we are able to analyze this? Well, we break down the major components into a number of what we call elements. Affordability and allocation and preference are all determinants of food access. The nutritional value, of course, and the social value, the social function food has, its sort of meta value, and food safety are all important aspects of food utilization. And then, of course, there's the primary production, there's the fact there's the distribution system that we rely upon, and of course there is exchange, whether it's exchange with our money or for our labor in the market or in international trading halls. So these 9 elements aren't just randomly chosen, but they are in effect distilled from the aspirational definition at the top. And the important point about this is that all 9 are important, and if any of the 9 begins to go down, then by definition food insecurity starts to go up. Many people focus on primary production and consumption in the food security discourse, but it's really important to recognize all of these 9 elements are important. If they're ignored, then we are not doing justice to the definition, aspirational definition at the top. So we know the overall food insecurity situation here in the UK. We've got about 67 million of us. 4 to 8 million at any time are hungry. This, I hasten to add, is just UK data. We also know that about a half of us have insufficient nutrient, although we're not objectively hungry. We're very well aware that getting on for half of us have excess calories for our dietary energy need, and many of those of us with excess calories are also suffering from insufficient nutrient. So sadly, less than half the UK population, and arguably the global population, is in the sweet spot. And this malnutrition, the 3 red circles, are really recognized now as the new normal here in the UK and internationally. And of course, malnutrition means bad nutrition. It doesn't just mean undernutrition. So anyone in a red circle is suffering from malnutrition. And here in the UK, the cost to the public purse is enormous, already approaching 10 billion estimate for 2050. And the wider cost to society from diet-related disease is a eye-watering number, perhaps 50 billion a year. So a serious issue to do with food insecurity. We're also aware of the issues of the environmental footprint of our food system. A lot of it, as these images are showing, are related to primary production. It's really important that we recognize the primary production impact, but we also recognize that overall, there are other aspects from the food system post-farm gate to do with the distribution network, the logistics, the retail, etc., which are all producing environmental challenges. And we know that overall, the food system is responsible for perhaps a third of global anthropogenic greenhouse gases. So a big environmental challenge. We're also aware, perhaps more globally, of the increasing issue of the interactions between the animal kingdom and the humans, us. On the graph, we see a number of major circles where human, wildlife, or livestock are captured. And the words in the overlaps are the diseases, which are known to be transmitted because either from wild or from livestock to the human population. So as pressure grows in demographic terms, we see an increase in the animal-human interface, and this is leading to the prospect of further disease. Of course, COVID would be writ large across this. But we're also aware of the challenge of antimicrobial resistance building up because of the prophylaxis, antimicrobial prophylaxis that is used very widely in the livestock industry. But there's another thing that we really must also focus on, and this is the ethical and moral issues that are underpinning the food system. Whether it's the intergenerational environmental legacy, whether it's workers' rights and worker safety, whether it's equity, whatever, these are all important aspects that often we don't consider enough in our food system discourse. So food systems, we have a number of activities in the food system, going from left to right, the primary producing, the processing, retailing, etc. These sorts of graphs are now very well known in the literature. We also recognize the fact that it's a wide range of people, or actors as they're technically termed, who are undertaking these activities. And of course, we are all on this graph because we are all consuming, we are all consumers. The activities, our behavior is determined by a wide range of drivers, different sorts of drivers, market opportunities, policies, climate and biophysical environment issues. And as the drivers interact with our activities and our behavior, it gives rise to what we call food system outcomes, which can be largely clustered in these three major areas of economic and social well-being, food and nutrition security, and environmental sustainability. So be it. But of course, there is a feedback from the outcomes back to the drivers because we are dealing with a system. And it's this dynamic that we study and where the nuances need to be understood. The feed forwards and the feedbacks are really fundamental to food system thinking. So at the top of the slide, we have the set of food system activities we've just seen, the things we do. And at the bottom of the slide, we have the things we get, the food security outcome. Also, I've noted already a wide range of other types of outcome, socioeconomic outcomes, and further, the environmental outcomes. There's no dispute about these issues. The challenge is the trade-offs that we see across these outcomes and the way that our food system activities give rise to an imbalance in some of these issues. You may find a negative environmental consequence and an outcome which is happening despite the fact there might be significant profit to a certain sector of the food system over on the left. So are these things in balance? The trade-offs exist. And what we're trying to establish, of course, is the synergistic interventions so that as we adapt the activities, we're actually having the win-win situation. This is what we're after. So the challenge that we have with the activities and the outcomes is balancing the what we want out of the system with the what we actually do, and therefore what we get. Very simple language, but it's the crux of the issue. We're aware of the call for food system transformation. This has got louder and sharper over the years, given a major impetus by the UN Food Systems Summit. And this was a paper that came out of the Inter-Academies panel some years ago now, saying it requires a radical transformation of the system. Okay, this is the call for food system transformation. But what does transformation of the system actually mean? What are we actually trying to transform? Well, my answer is related to the food system outcomes. We want to transform the food system outcomes from state A, less good, to state B, more good. Examples, poor diets to more balanced diets. We've seen the data. Poor environmental outcomes to better environmental outcomes. We've seen the data. But you can also think of other things. For instance, food crime, the current incidence of food crime reduced, better animal welfare, better working conditions. So these are all the outcomes of the food system activities. There's been a call for a shift in mindsets. This was a really valuable paper from Webb and Co. a couple of years ago, in which they say the urgency of food system transformation is now irrefutable. Very clear argument laid out in the paper, and they're saying it's going to require a major shift in mindset. And this is about what do we want from the system? What would we be happy with, especially regarding possible futures versus the status quo? Shifting our expectations from what we're currently getting, which is arguably less good, imbalanced, good for some, less good for others, to what we want to get, which is better for everybody and every aspect of the food system outcomes. So what outcomes are we trying to do and what do we want? First of all, we need to agree what outcomes are acceptable. What is the shift in mindset that we need to be satisfied with a different set of food system outcomes? And that means for who, from whose perspective, by when, etc. So that's a big societal level debate. Second thing is we need to adapt our activities so as to transform the outcomes from less good to more good. How do we do that? Who does it? Who's responsible? What are going to be the negative and positive benefits of doing that? And the argument flows that the degree of transformation in the outcome that we seek will determine the amount of effort that needs to go into the adaptation itself. So if we want to have a major transformation in food system outcomes, it is going to need a significant adaptation of the food system activities. And that needs negotiation. And it needs negotiation because with any intervention, there are winners and losers. The winners may be a company or a biodiversity metric. The losers may be another aspect of the business empire somewhere else over there tomorrow. But also, it may be a problem between some of the slides we were looking at earlier, viz. The moral and ethical outcomes versus the very biophysical outcomes. How do we balance and juggle such incommensurate concepts? This is a real challenge that we need to work on very, very skillfully. So the negotiation is fundamental to determining the future. I'd like to give you just the example of a project that we have in the UK called Bean Meals. The idea here is to say, how do we actually shift the entire system, the whole food system, in what we call a systemic innovation to improve both the dietary outcomes, the health, the environmental outcomes, but also maintaining vibrant business. So the systemic innovations are those that are requiring collaboration across the multiple actors using a food system approach. the 4 objectives to the project. One is to determine how to promote healthier diets, and we're using beans as a vehicle to do this. I'll explain why in a moment, to lead to lower fat, sugar, salt meals. Second, to determine how do we actually produce and supply sufficient beans and foodstuffs and ingredients. It's all very well to be promoting them, but how do we make sure the supply chain is there? Third is to say what would be the benefits, the environmental, health and enterprise benefits, and also the trade-offs where these new bean varieties scaled across the UK. And finally, to understand by analysing the work of the first 3 objectives, how to actually design and implement a systemic innovation that we're calling Fork to Farm. The project, briefly put, is a number of universities at the top, you can see. And we're using a couple of new varieties that have been developed by Warwick University in the UK, which have been developed, the navy beans developed for UK conditions. Currently our baked beans in a tin that we're all familiar with are essentially brought in from North America because we can't grow the suitable variety for canning in the UK. But now we've got these 2 new varieties that have been bred for UK conditions. A number of other attributes: they're quick cooking, low glycemic index, and of course they're a legume, so they're helping with nitrogen inputs for a subsequent crop. We're taking this, what we call a fork to farm approach, partly because it's disrupting the standard mantra of farm to fork, so that we do put an emphasis on what we eat in the first instance rather than what we grow. And over the 2 years, we're working in an English county in the middle of England called Leicestershire. And the reason for choosing that, it's got a great diversity, social and culturally, of wealthier areas, poorer areas, very, very diverse in many ways. But also there are some well-defined jurisdictions. And in this sort of a project, we're working very closely with the local authorities. There is a city level, there is a county level, and then of course there's the country level. And so we've co-designed the work with relevant bodies to make sure that we are able to discuss with them the challenges they face and the way forward that we might be able to offer. A number of private companies are also involved, but Food for Life is an important one in that it runs a network of schools. And because we're interested particularly in diets for school children using these beans, we're very pleased to have that partner. So 8 major research areas. What's the policy environment and what's the food system map as it currently stands? How do we change behaviors in the schools and the school kitchens, and how do we extend that to the community? What will be the benefits and trade-offs across health, environment and local enterprise? And how do we actually transform the food system outcomes systemically using systemic innovation and learning? Why is this? Why are we choosing school children? Well, if we go back to our circles we had earlier, insufficient calories, insufficient nutrients, sufficient calories, insufficient nutrients, excess calories, many with insufficient nutrients, and those less than half the population in the sweet spot. The question is, what determines which circle anybody falls in? So here we have the determinants on dietary choice. And if you can see the words in italics, affordability, preference, cultural norms, etc., those are very much the same words that we had in the food security aspirational definition that we were looking at earlier. This is related to food security outcomes. They will get their food through a procurement process in a school kitchen, and this very much depends on the food chain actors for the processing, the packaging, the shipping, the storing, etc., etc. And these set of activities are really setting the final calorific and nutrient quantity and price at the shop. Those actors are getting their material from the farm or from the ocean, and the activities there, of course, are the farming and the fishing, and they are setting the basic calorific nutrient quantity and price at the farm or at the harbour. And those actors are dependent on the natural resource base, and the way they manage the natural resource base, productivity and diversity and quality. So this is a fork to farm diagram But it's not as simple as that, of course, because there are massive feedbacks throughout the system because it's a system, and the feed forwards and the feedbacks are actually governed by the drivers that we saw earlier, the social, political, businesses, etc. Now, if we're interested in changing people from the red circle into the green circle, the question is, how do we influence the consumption patterns? And over on the left, we have a indication that the food environment, as it's called, which are the sorts of things in the dark blue box at the top, the food environment increases strength as you go up the diagram. And so understanding how to manage the people in the red circles and how to move them over to the green circle is very much a question of understanding the determinants of dietary choice, which goes through this argument, ultimately leading to the productivity of the natural resource base. So we've taken this approach we call fork to farm, and here we are, some photos in a school kitchen. They're using the new variety beans, as you can see. There's a brown bean and a white bean, and their school caterers are mixing them into a meal, which is served in the school canteen. The children are encouraged to try the food, and they're enthusiastic about it because they've been talking about the journey the beans have taken from fork back to farm during the school lessons, and there's curriculum built around the potential benefits and challenges of introducing new varieties into a school menu. The beans themselves are coming from an experimental farm, University of Warwick, and some of the school children have been to the farm when the beans were being harvested, so they get literally a hands-on feel for where their food has come from. The other thing that's been developed you might be interested in is a game. It's called Beantopia, and this was to consolidate the classroom learning. It was co-designed by the children over the course of some weeks, and they were given the task of come up with a game to describe the journey your lunch has taken, where it's come from. And over a number of iterations where they get more and more refined, we actually end up with a game that is played like a board game, a Monopoly game or whatever, snakes and ladders, whatever you want to think of. And this has proven hugely successful in encouraging the children and consolidating their knowledge in the journey, the health, the environment, and the potential local enterprise opportunities for using these new cultivars in meals. The children are taking it through to their parents, and the parents are discussing it in community groups. So we're hoping to have some impact. Now, just to conclude, who has to do what? So if we're after a transformation of the food system outcomes from less good to more good, we want better food security, better environment, and better social economic outcomes. This means that we need to adapt the activities, because the outcomes won't just spontaneously change. They won't transform from less good to more good unless we actually adapt our activities. We can adapt our consumption patterns, we can adapt our agricultural methods, etc., etc. But those activities and the actors who deliver them don't spontaneously change their activity. We respond to a signal. And broadly speaking, the signal is either an opportunity or a threat. It might be a new opportunity in business. It might be a threat, increased understanding about poor diet leading to ill health. It might be the risk of a piece of environmental legislation coming along to affect the way the food system operates. So a signal or a threat. So if we want to bring about an adaptation in the activities so as to transform the outcomes, we need to understand how to manage the signals. And the signals are in effect a combination of the food system policies, both in public and private sector, and the context within which those policies are set, the social, economic, the drivers, in another word. So this is what is actually sending the signal. Now, if the signal is acted upon and the activities are adapted so as to transform the outcome, because it's a system, we are in fact actually changing the very context themselves. And this is the dynamism that is the complexity of the system. How do we manage that going forward? Well, we can use scenarios to think about the shocks and stresses that might affect the system, and we can have exploratory scenarios to imagine plausible future contexts, or we can have normative scenarios to say this is what we'd like to transform towards. How do we get there? What development pathways are needed? But the important point about the diagram is that it's saying that our food system policies need to be continually reassessed because we are dealing with a dynamic situation. One of the challenges in policy formulation is to keep up with the status, but also to think to the future. And this is really where the scenarios are going to come in. So in essence, the food system has numerous opportunities for adaptation overall. The thing is to think about, when we say food system transformation, to remember, in my opinion, the thing that we're actually trying to transform are the food system outcomes. We want better and more balanced food system outcomes. That, to my mind, is what food system transformation is all about. So let me close there, if I may, just a couple of minutes over, but I hope that's given some interesting insights from our work in Oxford, a particular project we're involved in, where we are developing the food system concepts in very much hand in hand with the system approach. Let me hand back to you then, please.
Thank you so much, John, for that wonderful talk. Really appreciate your sort of big picture thinking about what food systems transformation actually means, as well as how to operationalize that on the ground and in schools, as the case may be. So we have, given my intro, we still have just a couple minutes for questions before we move over to Marta. So for all the attendees, just want to call your attention to, there should be a way to submit your questions here to the Q&A, and I'll moderate as those come in. So let's start with a question about demand. So what do you think, what will be the range of levers to actually manage demand when we think about?
Oh, excellent. Well, what is demand? What are we using our agricultural products for? Obviously, there's our food consumption, but then we use our many of our cereals for animal feed. We use cereals for putting into bioethanol. I think we're all aware that we perhaps lose 15% on farm, and we waste 15% post purchase. So those are all potential levers. And if one was to take 50% off all of those, rather than saying we have to stop completely any one of them, we would have a tremendous overall impact, which would be beneficial for health as well as environment. The question is, who's going to lose out? And this is the challenge, because it's a negotiation. And there are a lot of vested interests in the status quo. And so there will be a big challenge in reducing the amount of cereal going into animal feed, although on the face of it, it's a very sensible thing to do.
One more question for you. What do you see as the challenges from the producer side of things? Was it really the absence of the appropriate bean varieties, or is it thinking about the profitability of that system and crop relative to other alternatives?
Well, ultimately, the challenge for the producer is the market, and if the market changes, the producer has a problem. Obviously, technologies have been developed over countless years and will continue to develop. Whether the producer is able to capitalize on new technologies depends on a number of factors, but ultimately it's what's the market going to want. And as long as the market stays as it is, with these opportunities to grow for the animal feed industry or for the biofuel industry, then there is that ready market. There's so much political capital tied up in those things as well. But I think the real challenge for the producer is not technological, but very much more political and economic, and to make sure that the context for the market for the grower is still vibrant, while there will be fallout for some of the major changes needed. This is the negotiation that has to happen.
Thank you so much, John. We really appreciate your presentation and joining us here today. And so now it's my privilege to introduce our second speaker, Marta Tuninetti, who's also an editorial board member of ERFS. So Marta is an assistant professor in the Department of Environment, Land, and Infrastructure Engineering at Politecnico di Torino in Italy. Her interests span the field of water, food, energy nexus using spatial data science and hydrological modeling at regional to global scales. She also received her PhD from Torino and has been a departmental guest at Princeton University, a visiting research scholar at University College London and the University of Virginia. She will be giving a talk today on the big challenges towards a sustainable and robust food system. And if I understand correctly, Marta's traveling with slightly dicey internet, so we're gonna pray to the technology gods that it all works out. So take it away, Marta.
Thank you, Nathan, for the introduction. Yeah, I hope my connection stays stable. Okay, so hello everyone. It's a pleasure to give this talk. I basically centered my presentation on some of the big challenges toward a sustainable and robust food system. So being an hydrologist, I sometimes basically put also in these challenges the critical role of water resources. So you will see from my presentation a focus on the challenges of the food system that sometimes is strongly interlinked with the water resources, because as you know, food security depends on water security. They are interlinked. So before going into the details of the challenge, I want to present you what is currently the situation of the global water footprint, and thus basically what is currently the role of the food system in the requirement of water resources for its production. So here you can observe the geography of green water footprint. So basically the amount of water being stored in the root zone for the crop and being used afterwards by the crop to grow. And basically you can observe a purple area being the places where the water footprint is lower compared to the green places where the green water footprint is higher. And then we can have also a geography of the blue water footprint. So depending on where the food is grown, there can be enough rainfall to feed the crop water demand. And if not, irrigation might be available. So you can observe basically in the blue areas, we have an important blue water footprint. You can observe, for instance, some examples in the US, so the California Central Valley or the High Plain Aquifer, but then we have also important example in the North China Plain and here over the Indo-Gangetic Plain. So basically, when we speak about the food system and its impact, in this case on water resources, we need to have a global perspective, in my view, to these studies, in order to understand what is the global pattern, the geography of agricultural production and the impact on water resources. And this is important because 1/3 of the food we consume is traded in the international food system. So here is an example for wheat. I selected Italy, for example, and basically this map trying to show you what are the countries from where Italy depends in terms of wheat imports. So basically all the orange countries provide wheat, in this case, to Italy. So Italy is needs to be put in the global context in order to assess its food system sustainability, and in this case, the water use sustainability. And the green countries are countries where basically Italy imports its wheat products. So if we look at the 2016, we can observe that the globalization of food system and thus water resources increased. And this is very important to be taken into account, both for the sustainable food system and also in this case for water resources. So basically, I'm moving now to the first challenge. And as you can see, the first layer to food security is the geography. The second layer that also becomes, in my view, a challenge is the geopolitics. So the fact that, as we saw, the global food system is globalized. So here you have the whole network of the food system that is, for example, transformed into virtual water. But this can be applied also for carbon footprint, land footprint, and other type of impacts. Or we can also analyze it in dollars, in economics terms, for example. But the idea is that countries are interlinked. So every time we assess the food system situation in a country, we need to put it in the global context. So for example, here we learn that the US is an important player in the global food system. It provides food, for example, to China, to nearly all or almost all the countries in this network. And thus, it tends to use water resources that are then provided indirectly to the global network. Then we can have other examples. For instance, let's go back to Italy. Italy is purple because in this global food system tend to be a net importer. And determining if a country is a net exporter or importer of food is very important in order to understand its vulnerability to shock propagation and also its resilience. So depending on the commercial partners you have in this network, we can also measure basically what is your resilience. So if you're able to switch to another partner when a crisis impacts your producer, for example. So we need overall to improve the understanding of this network, basically. And in particular, we need also to zoom in into this flow, because basically behind each of these flow connecting countries, we have different actors. And also John was mentioning the key role of agency. And here I'm showing an example for the Brazilian soybean and the role that corporations have in these in the trade, basically, of soybean. So basically here I'm looking at one specific flow connecting the export of Brazil to Italy, but I'm decomposing this flow into different flows depending on what is the corporation managing this flow. And here basically you can observe what are the key corporations basically handling 80-90% of the total flow. And looking at the actors allows us basically to improve the resolution of the analysis in the food system, because basically we can understand from where a given corporation, for instance, here we have the production basket of Amaggi, but here in the south of Brazil we have the production basket of Bianchini and Gavilon. So by knowing who are the actors, thanks to their financial flow declarations, we can also set and quantify the specific impacts, because as you know, Brazil is a giant in terms of land extension. So it's very different cultivating soybean here in this area of Amaggi versus cultivating soybean here. You have different impacts on the local water demand, for example, but also on land use change and other different environmental indicators. So knowing the actors, having actor-based data, in a sense, allowed us to improve the assessment of the food system sustainability. And also it allows us to basically moving somehow toward the concept of food stewardship, water stewardship, in the sense that in the end we are all, or we should all be, like stewards of the food system. So knowing the agency and knowing the role of each actor in the food system help us in improving its sustainability and security. Then a third challenge is about consumer. So moving to the side of what we eat, basically, we can try to understand what is the current status of the food system and what can we do as consumers to improve the food system patterns, both from a health perspective, but also from a sustainability perspective. And here we analyzed basically what is the current status, so the reference year is 2018, of the food system on a global scale. So on the right, you have a map that basically split the world into 5 socioeconomic classes, from low to high level of socioeconomic development, and then the world is indicated in blue. So I put just here a few examples, and basically the bold line show us what is healthy and sustainable food system. So what is the amount of food we should consume, according, in this case, to the Eat Lancet Commission, in order to basically preserve our health and the health of the planet. And you can observe that, for instance, in the case of bovine meat, the food system on a global scale is basically over-consuming by 2.5 times the amount suggested by the Commission. Then for pig meat, this number is even bigger. We are reaching number 10 at the global scale. And then you can have a look at the heterogeneity. So when we move from low to high socioeconomic development, you can basically spot the Bennett law. So basically, as income rise in this direction, people tend to eat more meat-based proteins. So it's clear that, especially when we look at milk or poultry, the global food system is mismatched. So in some cases, we have a low consumption of milk, of poultry, and in other cases, we have overconsumption. In some cases, we have overconsumption for nearly all countries, with, of course, some exception. So basically, the idea is that what if there will be a transformation of the food system toward this diet that, of course, is just one possible example of a sustainable and healthy diet. So what would happen for the environmental resources? And we tried to quantify these for water resources. There was another study published in Nature Food that did the evaluation for carbon footprint. And so what we understood is that basically the transformation toward a healthy and sustainable diet can allow an important change also for water footprint, for the geography of water footprint. Overall, we can save around 12% of the global water use, water volume. And of course, there will be like here in Sub-Saharan Africa or in other countries, in red, basically, where water footprint needs to increase to meet the Eat Lancet diet. But then we have plenty of countries where the water footprint can decrease thanks to this food system transformation. Of course, in order to reach this transformation, we need a good synergies across countries, because as we saw in the previous slide, the food system is globalized. So also in this transformation, we need to put all the countries and actors on the same table. I hope my connection is still there. Just checking. Okay. Then another point that I want to mention toward the food system security, basically we also need to assess what is currently the vulnerability of food system. And because this is one of the pillars of food security, as mentioned also by John before, so about the stability of the food system. And basically in this map, we try to understand what are the places where an optimized management of water resources can help to reduce the crop vulnerability. And so basically can help the production sites to guarantee a stable production, so food security, in face of extreme weather condition. And basically here you have that in the blue pixel of the map, we can be able to extend irrigation, for example, in order to sustain the food system. And we can extend irrigation in a sustainable way. So we can somehow reach the sustainability of food system and also the sustainability of water resources. And this is the case, for example, of Western Africa. And of course, here I'm talking about the physical water availability. I'm not discussing the infrastructural constraint. Then we also have possibilities here in the eastern part of the US to extend, sustainably extend irrigation in some areas. But in the purple area, the irrigation cannot be sustainably extend. And in India, the example, is even more clear, as most of the area are in purple. So there cannot be an improvement of the crop vulnerability through irrigation. We need to find some other solution. And other possible solution can be, for example, the crop switching. So basically here we tested, but a lot of work still needs to be done. We're testing what's the role of crop switching. So in those areas where we cannot expand irrigation, is it possible to perform some crop switching that allowed us at the same time to reduce losses, so to increase stability of production, but also increase the productivity. And you can observe, for example, in Myanmar or Indonesia, or also in India, as we were mentioning, the role of crop switching can basically be strategic in synergy with the irrigation. So another challenge of the food system is the critical role of integrating solutions. And here we are seeing the critical role of integrating solutions for producers, but in a while we will also see something about integrating solution for consumer. Then I'm moving to, as I said, to the consumer part, and I'm almost close to the end with the 3 more challenges for our food system. So moving to the perspective of consumer, a possible way to study what can be our role. So we observe, for instance, that the current food system is over-consuming bovine meat, for example, or that in some countries we need to boost the consumption of other products. So what can be the role of society? So again, zooming to agents and trying to understand what can be a good intervention to boost behavioral change. So here, something that has been suggested by the Food and Land Coalition is basically to focus on the agent of the change and creating for them the enabling condition in order to move the food system from this current equilibrium, this current state, to a new state where basically the food system is more secure, health, and sustainable. Of course, this is just a sketch, this is just an idea, but here in analogy with the energy system, we're kind of proposing a possible way of analyzing changes and transformation in the food system. So by introducing positive tipping points in the food system, we may see acceleration in the transformation. And another role that we want to observe is that this positive tipping point, this transformation should happen by having in consideration also the role of teleconnected food system resilience, in the sense that when basically we envision a change in the food system, so for instance, we decide to grow more legumes or more nuts, as suggested by the Lancet Commission, then we also need to model, to quantify the impacts on land use in this case, and thus on the water cycle, for example. So basically, each choices in the food system should be put in a holistic framework, in a complex framework, because, for example, when we change and we clear, for instance, land to expand the nut cultivation or legumes cultivation, then we have impacts also on the water cycle. And so these should be put in our analysis. And then to conclude, as I was saying, we can basically synthesize, following the follow report, what are the basically critical transition of the food system. So by taking this perspective of global geography and geopolitics, looking at actors and their agency and trying to find solution to accelerate the transformation, we should take into account the different sectors where we can intervene. Basically moving from nutritious food, as we were mentioning, so healthy diet, but putting in the same complex system the productive and regenerative agriculture, for example, protecting and restore nature, looking at stronger rural livelihood, gender and demography, for example. So with these 8 challenges, I stop here with some final remark that maybe I leave here, and I stop my presentation. Thank you very much for your attention.
Thank you so much, Marta, for that fascinating talk on water food nexus and globalization and food system transformation. So we have a few questions for you. The first from Camille. She's interested in the particular case when countries are both importers and exporters for the same product. So she's wondering, kind of why that happens and to what extent it would be possible to minimize those sort of situations to save on trade.
Yeah, thanks for the question. So yeah, basically in the map I show, there was these multiple interlinkages between any couple of countries, because basically we cumulated all the food products together. But in many cases, as mentioned, there is basically the exchange of primary products from an exporter to an importer countries. Then the importer countries may transform the crop, the primary food, into a derived product that then can be resold to the original country. So there is a lot of interactions going on, because the supply chain can be very complex. So in some cases there can be also many degrees of steps moving from the primary products to the final processed, in some cases, products. So this is possibly a part of the answer.
Yeah, thank you. Another question for you. So how does the globalization of food systems and food trade in particular affect the efficiency of resource use in agriculture? For example, water footprint.
Yeah, thank you. This is a very complex question. So basically, there are a lot of, behind the food chain network, there are a lot of drivers. So most of the drivers are socioeconomic drivers. So we have the role of prices, we have the role of international trade agreements. And so the food trade, of course, is driven by mostly by socioeconomic factor, but then depending on the movements of food products, we can try to basically reconnect every importer to the original exporter or to the original producer. So basically, the idea of putting the environmental sustainability in combination with the international trade is that one of reconnecting consumers and the final importer to the original footprint they generate. And this potentially can help in improving the food system, both with a farm to fork perspective, but also in the other way around. As also John was mentioning, the role of fork to farm is fundamental in this case.
Excellent. Thank you so much, Marta. I guess.
Thank you, Nathan.
Yeah, I guess we'll go ahead and transition here to our next speaker, Navin Ramankutty. Welcome, Navin. Navin is Professor and Canada Research Chair in Data Science for Sustainable Global Food Systems at the School of Public Policy and Global Affairs and the Institute of Resources, Environment, and Sustainability at the University of British Columbia. He was trained originally as an engineer, but his interest shifted over the years to climate science, global ecosystem science, and land and food science. So today, his research uses global data and models to explore solutions for sustainably feeding humanity. And his talk today is titled Soft Paths for a Sustainable Food System. So welcome, Navin. Looking forward to your presentation.
Thanks, Nathan. I hope my screen share is working. Thanks for inviting me to give this talk. I'm talking about how do we move towards a sustainable food system. In my view, there are four main challenges when we think about food systems, and I think the previous speakers have already alluded to this. But in my mind, we have to tackle all of these challenges at the same time. First is, of course, that there are still 800 million people who are hungry today, and we need to feed them. The second is looking forward into the future. We have more people expected on this planet, and our consumption is increasing. So the assumption that we'll actually need more food in the future. Thirdly, agriculture itself is one of the biggest drivers of global environmental change. And lastly, our global environmental change itself might feed back on our food system. So for example, climate change is expected to have and is already having great impacts on our food system. So how do we address all of these challenges at the same time? And when you read the literature or read the news, you see all kinds of different solutions. So some people say we need to intensify our food production, but we need to do it sustainably. So this idea of sustainable intensification. Others may say we need to transition to organic farming, or that large farms are the problem and smaller farms are actually better. Yet others might say we need more technological interventions such as genetic modification, or maybe we can do vertical farming or urban agriculture. Yet others might say we need to switch to vegan diets or maybe eat more insects instead of eating beef. Yet others might say we need to, if the problem is about transporting our food, we need more local food systems, or we need to reduce food waste. Others might say, I'm sorry, I think I lost my screen share. Others might say we need to switch to agroecology or move to food sovereignty. So in my work, I've always found this kind of plethora of solutions to be quite confusing. I've always believed that there is no silver bullet, that one of these solutions by itself is not necessarily going to transform the food system. So some of the work I've been doing with my students and I is to examine, exactly what do we know about each of these solutions and what kinds of performance they have. So just to illustrate some of the work we've been doing in this space, I'm going to look at three of these solutions: sustainable intensification, organic farms, and small farms. And to do this work, I'm going to first also put them within an assessment framework and ask, what do we know about the performance of these systems compared to some kind of a baseline, maybe current systems, in terms of how much food they can produce, in terms of their environmental benefits, producer benefits, and consumer benefits. Because essentially we feel that a food system should offer all of these. It should produce enough food, it should be good for the environment, and it should provide benefits for both the producers and consumers. Okay, so let's first take sustainable intensification. And this is the idea that we can intensify our food production, grow more food per unit area, but do it more sustainably, do it better. And in fact, I'm going to draw on some work that I did along with Nathan and other colleagues several years ago, where we started by looking at yield gaps around the world. And this is an illustration of our estimated yield gaps. The green areas have smaller yield gaps. The red areas have larger yield gaps, which essentially means that farmers in places that are in red could actually close yield gaps by applying more inputs. They're not doing as well as they could be compared to other parts of the world. So the idea is that you can close yield gaps and produce more food. But as we all know, adding more inputs is part of the problem. And so we need to close these yield gaps much more sustainably. And we would call that sustainable intensification. And Nathan himself did some work. This is from one of his papers where he looked at how can you close yield gaps by optimizing the nutrients being applied and water being applied. And this is just a map for nitrogen. All the places in green are places we can actually de-intensify a little bit because these are in some ways places that are highly intensive. So Western Europe, North America, Eastern China, for example, we can actually give up a little bit of nitrogen with not a huge penalty for yields. But places in red, we can actually increase nitrogen inputs and get a big benefit for yield. So we can try to close yield gaps sustainably by sort of optimizing inputs around the world to get the biggest bang for that buck. And in Nathan's paper, they estimated that 29% increase in production can be obtained with just a 9% increase in nitrogen. So essentially, you can get a big bang for the buck in terms of optimizing nitrogen use efficiency around the planet. But let's put this into our assessment framework. What it would show is that, in fact, we are able to increase our food production by about 30%. But it continues to be worse for the environment. Even though it's more efficient, you're still increasing nitrogen inputs by 9%. And in fact, we're also increasing irrigation inputs by 25%. So even though it's more efficient, it's still worse for the environment than the current state. We haven't done an analysis to know exactly what this would mean for producer and consumer benefits. So I'm not going to talk about that. Okay, so if sustainable intensification has this trade-off, let's now look at organic farming. And this is work done by one of my former students, Verena Seifert. And we can ask the same question, is organic better? And in a review paper, we reviewed organic performance across 11 dimensions and 26 different criteria. And we looked at these 4 benefits. Here's a summary from our work. It shows a kind of a flower diagram, and the red petal shows how the red circle around these flowers shows the baseline. If the petals are outside that red circle, it means organic is better. And if the petals are within the red circle, organic is worse than conventional agriculture. And our review showed that organic does seem to have a lot of environmental benefits. It's good for biodiversity, for soil health, water quality, and for climate. It also seems to have benefits for the producer, seems to have benefits for farm workers. It does seem to have some benefits for consumers as well in terms of lower pesticide residues. But organic has 2 major drawbacks. One is that its productivity is lower than conventional agriculture. So it's about 20 to 25% lower. Organic also is also more expensive for consumers. So it has higher prices. So if you put that into the assessment framework, you find that with food production, organic is going to produce less food, even though it does have environmental benefits. We also think that it can be beneficial for the producers, especially if there are premium prices for organic agriculture. But for consumers, it's not a benefit because it's more expensive. Okay, so what about smaller farms? a lot of people say smaller farms are better than larger farms. And so the former PhD student of mine, Vinny Ricciardi, looked into this. And we asked the question, do smaller farms have higher yields? Are they better for biodiversity, greenhouse gas emissions, resource use efficiency, and profits? And to examine this question, we again did a meta-analysis of the literature. What do we know from the literature on these issues? And we found across different studies that smaller farms, that when you just look at whether studies report whether smaller farms are better or worse, we find that for yields and biodiversity, there's a higher probability that studies would find that smaller farms have higher yields and higher biodiversity. The yield result is not a surprise. Agricultural economists have been studying this for a long time. It's called the inverse farm size yield relationship, that it seems to be that smaller farms have higher yields. But we also found that smaller farms do seem to have higher biodiversity as well. But we had no null result for resource efficiency and profits. Another type of analysis where we actually were able to do kind of meta regressions, we found that for every 1 hectare increase in farm size, yields would decrease by about 5%. But we had null results for greenhouse gas emissions, profitability, and resource use efficiency. Essentially, for those three, we can't find a discernible difference between small and large farms. But the big drawback for smaller farms is that smaller farms have lower profits per capita. So essentially, even though profits per hectare may be better, profits per household is worse. So larger farms are more profitable for the farmer, essentially better returns to scale. So we put this back into our assessment framework. We find that smaller farms can produce a little bit more food. They might be better for the environment in terms of biodiversity. We didn't find many differences for other environmental impacts that we looked at. But the big drawback is that it provides lower profits for the producers. And we are not really sure about the consumer impacts. We think that's, because it's more, that it would, just like with organic, that it would be more expensive if we sourced all of our food from smaller farms, because producers would have to add a premium price. So my assessment of these three major solutions that people talk about is that there are trade-offs, trade-offs. And predominantly, when we look across supply-side solutions, we find that trade-offs seem to predominate. So then we have to start thinking about, what about demand? My feeling now, having done this research for several years, is that supply-side solutions, we always seem to be kind of fiddling at the margins, in the sense that we have really small benefits for a lot of effort. But when we start looking at demand-side solutions, we might be able to gain more benefits. For example, when we shift diets away from meat, previous speakers have talked about this already, 1/3 of grain is fed to animals. So that's a huge benefit to be had there. Similarly, 1/3 of food globally is estimated to be wasted. Again, there's huge benefits to be had there. The other nice thing about demand-side solutions is that, in fact, there is a double benefit to focusing on demand-side solutions. And this is an illustration trying to show that. Let's say we have a 2050 target of how much food is needed, and the blue bar shows how much calories are being produced today. You can think of that, the difference between those two as a calorie gap. And a typical supply-side solution would say we need more food, and so we are going to fill that calorie gap by sustainable intensification or other kinds of supply-side solutions. But what a demand-side solution does is that, on the one hand, by shifting diets or reducing waste, it frees up today's calories. So all of the food that's being produced on our farms today, more of that is available in terms of calories, rather than being wasted to feed or biofuels or other things. But additionally, it also reduces the 2050 target. Not only it frees up calories today, but future people are also going to need less food because they have shifted their diets. And so the kind of gap to be filled is much smaller than it would be with the supply side solution. This is well known by water resource engineers. Like if you fix your water leaks today, it actually reduces water demands for the future. So it's a similar idea. So this all leads me to, this is an illustration of the shifting diets idea. This is a work by a former colleague, Emily Cassidy, showing the kind of bang for the buck that you can get with shifting diet. This is just a thought experiment that says what happens if people switch to vegan diets. You can see that in places like Africa and India, a lot more food calories would be available. So these are places where the food that's grown today is actually feeding people, while in places like North America and Europe, much fewer food calories are being produced today. So Emily estimated that by shifting to a vegan diet, we can increase the amount of calories available by nearly 70%. That's a huge bang for the buck. So leveraging both supply and demand side solutions can more effectively address our food systems challenges. We can't just focus on supply side solutions. So taking inspiration from a paper done in the 1970s by Emery Levins, who was looking at the energy solutions in the US, where with increasing energy demands, people were talking about building more power plants. And Emery Levins said, we should look at this problem differently and not just build more and more power plants to meet the energy demands, which he called hard paths, but we should think about soft path energy solutions, which focus on more energy efficiency solutions, as well as switching to more renewable energy. So taking a similar analogy for food systems, a soft path to a sustainable food system would look like this. And this was a paper that one of my former colleagues, Hadi Dawlatabadi, and I published in ERL in 2021. Hadi is an energy system scholar, and we collaborated on drawing kind of insights from Emery Levins to looking at food systems. And in the paper, we go into more detail on kind of analogies between energy and food. But the summary is that we can focus on 3 different kinds of strategies. First is just to reduce overall demand, reducing dietary excess, shifting to plant-based diets and less biofuels. The second is to improve efficiency. So this is now on the supply side to both improve water and nutrient use efficiency on the farm, but on the demand side to reduce food loss and waste. And the last is to make agriculture more environmentally friendly. We should run lots of different experiments looking at, sorry, I think I lost my screen share again. We should be running lots of different experiments looking at different kinds of alternative systems that can be more environmentally friendly. Thank you very much. And with that, I maybe stop sharing.
Thank you so much, Navin, for that very thought-provoking talk, and really appreciate the systematic framework for evaluating this solution space. So in your talk, you seem to be a bit skeptical about technological solutions, and I was wondering if you could just elaborate on that, or any other technological solutions beyond those which you discussed.
Yeah, that's a great question. I'm skeptical that technological solutions alone can do it for us. That as I said, that we're fiddling at the margins with technological solutions. But I don't actually believe that we should step away from technology. One of the ways that I've been starting to think about it is that we need to think about these solutions also in different time scales. So in the short time scale, I think we have lots of challenges that are in an emergency setting, climate change being one of them. And I think we need to deploy all of our solutions possible at the same time. So technology plays a big part in my mind in terms of the short term. But as we know, technological solutions have this problem called the Jevons paradox. As we make things more efficient, we end up consuming more. And to avoid that in the long run, I feel like we need to shift our cultures towards lower demand. And so I sort of see these across 2 different time scales.
Yeah, and picking up on that last note about this long-term transition towards lower demand, how would you suggest we go about shifting diets to become more plant-based, and what sort of policies or actions do you see as most valuable or most effective?
Yeah, I think the biggest policy or the biggest solution these days is that just awareness about how plant-based diets are good for health. This is the one thing I feel like I've talked a lot about trade-offs, but here's the win-win where, shifting to plant-based diets can be good for our planet and good for health. The Eat Lancet report illustrated that really well. And I think, that in many parts of the world, especially in the US, there's been a switch away from red meat towards more poultry consumption. And apparently that's a result of people being aware that red meat consumption is bad for health. A lot of the food guides are starting to become more, progressive in that sense as well. So the recent Canada food guide that came a few years ago, the assessment was done based on just health impacts and promoted a much more plant-based diets. A lot of the health literature shows that lack of consumption of fruits and vegetables is the biggest diet-related cause of health problems. I would also say, I think our culture as a whole has forgotten how to cook plant-based foods, and so kind of culturally learning to do that is important. I also place some faith in technological solutions like the Beyond Burger and Impossible Burger, the kind of plant-based meats that are coming up. And there are more kind of radical solutions that some countries have been advocating, putting tax on meat, for example. People eat more meat because when it's cheaper, and so making it more expensive can help.
Definitely. And on that point, just mention Hannah Ritchie, who runs Our World in Data, just had a really interesting Substack post about kind of the costs of these meat alternatives and kind of the need to decrease the cost so they become more attractive and get greater uptake in the market. Another question for you. So you have the really interesting studies on farm size and the role of small farms there. And my perception, and you can tell me if my perception is correct or not, is that small farms tend to have a lot of family labor and in some cases child labor contributing to maybe that productivity boost, maybe some sort of substitution of labor for inputs to the extent that that's possible. But at the same time, to meet SDGs, we're trying to prioritize education and career opportunities for children and particularly girls around the world. And so I guess I'm just wondering to what extent, you see kind of the labor issue as a constraint on the role of small farms as a solution.
Yeah, that's a great question, Nathan. The agriculture economics community has been wrestling with this for a long time, trying to understand why are small farms. I mean, they kind of take it for granted at some level that smaller farms have higher yields, even that's now being questioned. But if you take it for granted, they've been asking why, and there are actually lots of hypotheses for why, and one of them being this issue of free labor from family farms. I don't think there's a consensus yet on that being the reason. There are other reasons that are out there as well. But I take it. I agree with you that given the circumstances today, given the political economic situation we have now, it's not the most profitable way for a farmer to practice farming. Like it's without subsidies from their own family labor and especially children in some countries. So how do the other way to think about it is from a public policy perspective is that if we actually want the benefits that smaller farms provide, especially in terms of biodiversity, for example, how do we as a society support that? With organically supported with premium prices, maybe putting a premium prices on foods that is produced by smaller farms can be can allow a farmer not to use their children for labor, for example, right? Like to put it more crudely, yeah.
Yeah, thanks. So we have a question here from Vidya. She asks, how do you see the future of aquaponics in the food system, and how can that be addressed sustainably?
That's a question I can't answer. It's not something I've looked into greatly in depth. All I will say is like I'm a fan of experiments, so I see lots of people trying to come up with creative solutions. Aquaponics is one of them. Vertical farms, indoor farming in all kinds of different configurations, plant-based meats, and so on. And we should let these experiments run and see what wins and what loses. It's like let 1,000 flowers bloom. I can't specifically ask about aquaponics, but I'm glad that people are trying different solutions.
Thanks. Cletus asks, how can we manage food system development with human cultural food diversity? So I guess, yeah, what role do you see for this sustainable transformation in light of the cultural diversity about diets across the world?
That's an excellent question. It's really interesting that people who have looked at diets around the world have found that in some ways diets are really diversified. Like if you live in North America, for example, the access to different kinds of ethnic cuisines is enormous. So in countries, diets have diversified. But globally speaking, diets have become more homogeneous in the sense that the McDonald's of the world or whatever, like it's spread everywhere. But it's very clear that some diets are culturally super important and very, very hard to move, which in some ways is a good thing. So countries like Asia still are, despite all the globalization, they're still less meat intensive than other countries. At the same time, I guess he's talking about dietary diversity and cultural diversity. I don't think I've studied that very deeply, but I suspect those two can go together and do go together. So as our cultures become more homogeneous, our diets are likely to get more homogeneous. I don't think that's a very good answer, but I'll think about that. Thank you for the question.
Thanks. Maybe a final question for you, depending on time, but you had that great sort of grab bag of solutions that people throw up at the beginning of your presentation, including vertical farms and some other ones that you didn't focus your talk on. And I'm wondering, of those other possibilities out there in the solution space, if there are any that are particularly appealing or interesting to you, or that you're motivated, or in the process of looking into. Yeah.
I'm trying not to get drawn into silver bullet kind of solutions, but
yeah, for sure. Or maybe they're interesting.
We're trying not to pick
because
one.
You think they're a terrible idea.
No, okay. So I say that I thought plant-based meats was a terrible idea. So I'll talk about my own change of mind, right? I used to think, how the heck are people going to make plant-based meats in an affordable way? And I've changed my mind around that somewhat. Like plant-based meats, like the Impossible Burger or Beyond Burger, are slightly more expensive than the regular fare, but not that much more. And I suspect that as they become more popular, unfortunately, it looks like they've kind of plateaued right now. But it's interesting that they are in the market. I never thought they would get to the market at such a large scale as they have. So I've changed my mind around it, and so I've come to the view that what I mentioned earlier, that we need to let 1,000 flowers bloom, because we never know what's going to scale up.
Yeah, I definitely agree with that. Well, thanks again, Navin, for the thought-provoking talk. And we're going to move on to Pinki Mondal. So Pinki's our fourth speaker of the day, and she is also an editorial board member of ERFS. Pinki leads the Earth Observation for Sustainable Ecosystem and Livelihood, or EASL research group at the University of Delaware here in the US. She is an assistant professor in the Department of Geography and Spatial Sciences with a joint appointment in the Department of Plant and Soil Sciences. She's a resident faculty at the UD Data Science Institute and is affiliate to the Delaware Environmental Institute in the Water Science and Policy program, as well as the Center for Food Systems and Sustainability. Dr. Mondal is an environmental geographer with a geospatial data science focus and is interested in the dynamics of coupled natural and human systems. So her talk today is going to be titled Satellites for Sustainability, a Geospatial Approach for Agroecological Landscapes. So welcome, and please take it away.
Thank you, Nathan. Well, good morning, afternoon, evening. I do see a lot of people, and I'm hoping they're from different parts of the world. Thank you for joining us today. So I would be focusing mostly on how I utilize satellite remote sensing, a little bit of aerial remote sensing on today's talk. And I'll be focusing on how we can utilize these technologies to learn more about sustainability, focusing on agricultural landscapes. I would like to start with a broad overview of my academic training and journey so far, especially thinking about early career researchers who would like to pursue interdisciplinary research. So I am a trained environmental geographer, geospatial data scientist, currently working at the University of Delaware. I was trained in geology. I have 2 degrees in geology, and for my graduate research, PhD research, I focused on forest cover and how it changed in a tiger reserve in central part of India. For my first postdoc at the University of Massachusetts, I focused on private forests in the USA. And my second postdoc at Columbia University took me back to the same landscape where I started my PhD journey, but now focusing more on how smallholder farmers are being impacted by climatic changes and how crops are responding. So I like to take a holistic approach whenever I'm studying a landscape, because most of the times all these landscapes are highly heterogeneous. So when it was the time to name my own research group, I called it an Earth Observation for Sustainable Ecosystem and Livelihood, or EASL, because we work in landscapes across Asia, western part of Africa, North America, but there's something common in all these landscapes. These are all highly human dominated, and there's a significant human footprints. And what I mean by that is that all these landscapes, they're multifunctional. We have the same landscape, we have forests, we have farmers, and we have different ways these landscapes are interacting with us humans and how we humans are changing these landscapes. These make it very my life as a satellite remote sensor very challenging, and I'll tell you why. But today I'll take kind of an approach where we are examining these landscapes through the eyes of the satellite, keeping in mind that many of these landscapes are also water challenged. Many of these landscapes are incredibly challenging to study because how these different land uses compete with each other. So it's not just agriculture that we are thinking about. Maybe there are other competing land uses. So for example, it could be conservation versus development, or conservation versus farming, and different types of farming. And today I would like to convince you that we need to take a nuanced approach in studying these landscapes rather than using a broad brush approach. So again, we'll be focusing on water challenged landscapes in different parts of the world, just for today's landscape, today's talk. So I'd like to start with this study showing this map that was published in 2016 in Environmental Research Letters, where this map showed, the distribution, the spatial distribution of small-scale farms across the world. Here in this colors, if you see the reds and oranges, those are the areas where we have smallholder farmers. And by smallholders, we are focusing on any farms that is less than 5 hectares, so very, very small farms. And if you see this map, you realize that most of these farms are distributed in Southeast Asia and Sub-Saharan Africa. And in this box, there are some numbers, and I would let that number convince you why we should focus on the smallholder farmers, because from my perspective, these are not the producers, but also consumers. If we focus on these farms, we are not only focusing the farms from the food production point of view, but also these families, these farmer families, actually over 380 million households. We would be able to use some science-oriented intervention if needed. But before that, we really need to understand what's going on and where, because place-based reality is very important. I'd like to use India as an example because I believe India represents many of these climatic and non-climatic changes that's happening there, but also happening in many other countries across the world, where we see smallholder dominated farming practices, but also these farmers not having very high technology, so they rely on traditional farming practices, but they're also experiencing extreme climatic events such as flood and drought. From the same year that that paper was published, you see some of these devastating pictures coming out from the field covered by CNN or Hindustan Times, where you do see farmers experiencing these extreme climatic events. Now, climatic events is obviously one part of the entire story. There are other non-climatic factors that we need to think about whenever we are thinking about these different landscapes. But one way to look at it is how much water these landscapes need and what we can do to maintain the viability of these systems, not just from the production, but also the consumption point of view. So it's important to realize that some parts of the world are experiencing this huge groundwater depletion. In fact, in this map, what we are seeing is these huge peaks, black peaks. The really dark colored peaks are literally the mountains of groundwater depletion. So you can see why India is called the capital of groundwater depletion. In this next map that I would like to share here on the left side of the slide, you see the areas in reds and oranges. That's the potential of groundwater availability in 2025, which is just around the corner. And you can see most part of this country are going through this groundwater depletion, literally not much water left for food production or agricultural uses. Now in India, it's not just groundwater, right? It's also the surface water, but that's kind of tied to the amount of rainfall and the timing of rainfall that we receive in a particular country. And I'm sure it's not a unique case in India. There are other countries which are going through these very erratic changes in climatic patterns. And when we talk about groundwater availability in any kind of system, what we need to understand is that there's definitely an inequity that's in place. So for example, on top right, you see a farmer in central part of India carrying these pipes. What this person is doing, that he's probably lending water from a wealthier farmer who had the money and resources to purchase that water available for irrigation. And then other not so wealthy farmers, they are renting that water access for their farms. Now what happens is that obviously if you don't have the money to lend that water or borrow that water, you don't have the chance to do a second crop. In India and in many parts of the world, the second crop often denotes a dry season crop. So as a farmer, you would always go for the first season or the rainy season where you have abundant water. But then if you want to maintain the food security of your family or maybe for the market, you would go for the second season or the dry season when you probably need the irrigational support. Now, coming from a policy perspective, it's very easy to promise, irrigation to support this second winter crop. And by the way, by winter, I mean a very mild winter in India. So maybe in 70 degrees Fahrenheit, so not too cold to grow, let's say, spring wheat or winter wheat. What we realized while working on this project, it was a series of different papers, multiple papers actually, where we looked at different components of climatic and non-climatic factors affecting this winter crop, is that it's not just the irrigation, right? It's also the timing of different climatic factors, especially winter temperature. So even if the farmers do have access to irrigation, just having a very warm winter might really affect their winter food production. So just promising the irrigation might not solve the issue or the challenges everywhere in the world. And that's where I really came into this advocating for place-based realities, because if you just use a broad brush approach everywhere in the world, it might not affect, because the goal is to create a sustainable food system that is not just sustainable from the production point of view, but also it's a fair system, it's a just system. And for that, we really need to understand what's going on in each of these places, which are really unique in terms of all the different factors considered. So as we are discussing for the last last talk, that labor also plays a huge role in whether these farmers or these farmer families would be able to do a second crop. We also find similar evidence in our studies that it's temperature, it's access to irrigation, it's labor availability that's really driving this winter food situation. But then what I got interested in this, understanding or examining is, let's say, if we give this support of irrigation and we make sure there's a labor market that is available to the smallholder farmers, would it make sure that these farmer families are food and nutrition secure? And the keyword being nutrition here, because there has been a long history of researchers discussing about not just food security but also nutrition security, and it's immensely important to consider both. And if we think about the UN Sustainable Development Goal 2 and zero hunger, we also need to make sure that it's not just the hungry people we are thinking about, we are also thinking about children who are not malnourished. So we need to make sure that we develop, or at least hope to develop, a system which would not just make them food secure, but also nutritionally secure. So coming from that point of view, when I was working in central part of India, trying to understand how I can use satellites trying to identify where farmers are developing, or practicing second farming or second cropping, there are some things that you cannot see through satellites, and that's something I realized while working with these farmers on the farm fields when I started talking to them and asking them questions. And some of these questions that I was thinking that, is multiple cropping necessarily associated with dietary diversity and improved food security and nutrition security? And do women farmers have nutritionally adequate diet, which is very, very important, because I would see that in many places the women, they do not have access to adequate food and nutritional food, even if the family itself, the household itself, is food secure. And I can give you the answers to both of these questions right away. It's no and no, which is kind of sad, but this is something that we realized after collecting unique household data from 200 different households over 2 years for 3 seasons, because we tried to understand if having a second crop would really help them in terms of having this household level food and nutrition security. What we found out is that they're not in abject hunger. This situation might change in another part of the world, but in this landscape in central India, they were not in abject hunger, so they are mostly food secure. And that was coming out of our analysis of household level food insecurity axis, the bottom panel. But then we started asking questions about what exactly they are eating, and is there a link between what they are growing versus what they are eating. And we found out that they are not really eating well. They were mostly eating cereals, which is, a cultural linkage there. So some vegetables, depending on the season that we are in, not much animal protein, but not because of any cultural link, mostly tied to affordability. And then we really looked into whether the women in the families, they have a nutritionally adequate diet or not. We found out that over 96% women farmers do not have iron-rich food. They're really lacking in protein as well. And when we started talking to these people that, okay, if you cannot afford meat or fish or eggs, how about plant-based, protein, for example, legumes? And we realized that they are not so much into farming legumes, although we think of it as a really, a good option for a second crop. And they said it's not just the irrigation, but it's also the soil type. The soil type in that location, in that geography, it was not really feasible for doing legumes. So that's when we realized that it's probably easier to recommend certain food groups or certain food items or even crop items to say, hey, why don't you go ahead with that? Because we believe as scientists that this works. But there's so many other factors that oftentimes maybe we are not thinking, especially it's difficult to do field-based research, but it's also very important to take into account the cultural aspect of it, the preferential accept for it, and what I saw that, especially the young generation, they're very much into junk foods, which are making it really, really into these markets, local markets, but not so much into a balanced and nutritional food. So there's definitely a lot of work that needs to be done to realize this, different places and how we can develop an agricultural system that is not just sustainable production-wise, but also consumption-wise. But what about a system which is not challenged by lack of water, but a lot of water and not the right kind of water? And I will bring you back to where I am right now, the eastern part of the USA, especially focusing on the coastal counties in Delaware, Maryland, and Virginia. We call it a Delmarva Peninsula, and again, I use it as an example because many places around the world, we have low-lying areas or regions that are fighting with sea level rise, land subsidence, competing land uses. And I would like to use this as a test case to show what can or cannot be done. Here we are talking about a phenomena called saltwater intrusion, where we do see ocean water, salty ocean water coming onto the farms. So if you look at the top left of the slide, you would see some white patches along the farm fields. Those are salt patches. It's basically very salty water that saturated, all these farms are saturated with that, and after the evaporation it leaves behind white salt patches. A lot of the Delmarva Peninsula is covered by farmlands, which lies very close to the open ocean water. As you can see in the second picture there, a lot of brackish water, and there are a lot of canals and ditches that were initially designed to take the excess water from the farm out in the ocean, but now they're being used by nature as conduits of bringing this ocean water onto the farms, because we are seeing more and more very powerful coastal storms. So now here these farmers are fighting with nature almost, because Delmarva is primarily a corn or maize, soybean economy. These corn are produced to support the poultry industry. So not so much for human consumption, but it comes through us, through the poultry industry. And corn does not like salt too much. So what we were interested in understanding that, okay, if we are seeing these salt patches, what's going on the rest of the farmlands? Because even if we do not see the salt on top of it, the soil might be too salty. And it turned out we were right, because field-based measurements of electrical conductivity of soil salinity revealed that even though when we do not see the visible salt patches, the soil salinity is really, really high, hundreds of meters away from the salt patches. And that kind of, compelled us to look at, so how much we are losing in terms of profit and how these salt patches are growing in space and time. And that's what we report in our recently published paper, So feel free to go ahead and take a look at this paper, but I'll give you a little bit of background here because this is not a new phenomenon. 6% of land globally is impacted by salt. Many other countries, as I mentioned, especially the low-lying region, are witnessing these changes. In many places in the US also, farmers often use saline water for irrigation, and again, it's not a new phenomenon. The way the remote sensing is coming into play is that before we used to examine the plant health or the crop health. If it's a reduced health, that means it's being ailed by something. But my issue was that how do we know it's because of salt? Because crop health might be reduced for many different reasons. There could be temperature issue, there could be a lot of precipitation issue. And before, we were looking at examining this reduced crop health through satellite remote sensing. And here in this study, I'm focusing on the salt on the soil surface, so the visible salt patch, and I'm using it as a clue to this silent disease, as we call it, a silent killer. But the other thing that was also very interesting for me or my lab group was looking at how these productive farmland is changing into marshland, because there are marsh species that would love that salty water environment. And so it was kind of seeing how this farmland is changing over the time. What was making it more interesting is that in many places the farmers were in denial. They really did not see this happening, and in many places they still don't, and they want to keep this land in production, whereas it was very clear from our study and also from all these field visits that we have made in different parts of Delmarva, that marsh is slowly taking over this agricultural farmland. And what we are hoping to establish with this study, and also raising awareness, talking to people, talking to media, is that the time for action is now. Because what we are already seeing, that many of the places across Delmarva Peninsula, they are changing into salt patch, and once it changes to salt patch, there's almost no go away. You might not see it every year, but that does not mean it's not there. And even if you are not seeing the salt patch, your farmland, productive farmland, is kind of changing into marshland gradually. But if we do not take action right now, what will happen is that it will be way too late and there's nothing that can be done. So we are working with state level agencies and farmers sometimes whenever we can, to identify what we can do right now, because there are different ways of doing it, and it also depends what the landowners want. And that's something I would also like to highlight, that in order to make any system, any agricultural system, ecological system, to make it sustainable, we really need to work with the farmers who are on the ground and see what they want. And that's also the sense of urgency is very, very crucial here, because at some point they will lose that option. Right now, there might be different options, for example, different crop types. So there could be other crop types like sorghum, barley, asparagus. They kind of do okay, especially depending on the level of salt we are seeing here. So depending on the geography, the location of that particular farm, the farmers might have the option to switch to a different crop types. But in some areas, it's just the level of salt is so high that there's no other way rather than going into a non-food crop, right? It could be a grass, or it could be totally, changing into a marshland, which, by the way, might have another ecological benefit. So there could be a meadowland or maybe a controlled conversion to marsh that might support local wildlife, but also pollinators. So we are also looking into these other options that are available to farmers. But again, we need to talk about this, and we need to discuss this at different levels, bottom up, because without that, it's very, very difficult to sustain any kind of ecosystems, especially agricultural systems where we have consumers and producers. So I'd like to thank my former and current graduate students, without whom we cannot do this work, and all the funding agencies that we have. And I would be happy to take any questions that we have right now.
Great. Thank you so much, Pinki, for that wonderful talk. It was super interesting to see the application to some of these different huge challenges in different regions around the world. So quite a few questions for you. One from Ragavi is, what is the effect of soil salinity on the quality of the crop produced for consumption? I guess in the case of Delaware, maybe it's consumption to the chickens or poultry, but also, if you know, for human consumption as well.
Exactly. So what we saw is that reduced yield. So not so much the quality of it, but the reduced yield. And that was one of the challenges that we faced when we are trying to talk to the farmers, because they were not realizing that it might be because of something that obviously they don't see. There's a reason why we call saltwater intrusion the invisible flood. So it slowly kills the crop, and before the crop is completely killed, you might not realize that your crop is slowly dying. So we are seeing a little bit of reduction in yield over the years. And what I showed you was between 2011 and 2017. Things have worsened since then, and it's almost it doubled in area between the salt patches between like in 6 years. And the numbers might be small, but they're just expanding. And what is more concerning is that how much farmland we have within these visible salt patches, so affecting the overall yield. And what we report in this paper is the reduction in profit. So we are not even looking at if we are losing the crop entirely, which means a failed crop, but it's a reduction in profit. And that's what makes it more concerning, because you are losing money without knowing, and you are planting and you are putting in a lot of money in there, and you're losing money over the years. And we calculated it to be over 107 million for corn per year. And that just losing the profit, not even losing the crop entirely.
Yeah, that's pretty sizable indeed. So Julius asks a question and draws the analog to Bangladesh, where there's a lot of rice being produced, but the diets are generally low in vitamins, and that is pretty common in the major cities there as well. And also that a lot of food is supplied but ends up being unsafe due to contamination along the value chain. And so the question here is, how can remote sensing data assist to detecting vulnerable agricultural landscapes, potential food insecurity, poor diets, and unsafe food and water?
That's a great question. What I love about remote sensing is that it makes me a time traveler without knowing any other source of doing time travel yet. I'm always hopeful, but you can always go back in time, almost late 70s, early 80s, to look at how that particular landscape has changed over the years. And almost all the landscapes that I have worked on, I have worked in India, Vietnam, a little bit of Bangladesh, western part of Africa, and a little bit of northeastern United States. The changes are happening rapidly over the last few decades. So the changes started maybe in 70s and 80s, but it really ramped up. And that's the reason I always, advocate for the change, that the time for action is now, because we cannot just wait for another 10-20 years to see how this unfolds. So I think knowing the history of the landscape really helps, and satellite remote sensing can help us with that. And then you just have to take that science to inform policy. So as researchers, I think it's a huge responsibility for us to make sure that our science is actually finding its route to the proper policymakers. Well, obviously, we need to make sure that the right people who would value science are in office, but then to make sure that our science is finding its way there, because without the science-informed policy, it's really, really difficult to make changes, bring changes on the ground, because satellite remote sensing can give you a way to find answers, but it cannot change the system. So that's on us as citizens, as scientists.
Definitely, thanks. So I have a couple questions of my own as well. One, this groundwater depletion situation in India is definitely seems very concerning, in this ability to get the second crop in the ground and harvested. And so I wonder if you could talk just a little bit about the consequences of losing that second crop for the farmers, or for regional food production or food prices. You know, if this becomes like a bigger and bigger phenomenon, how do you think that will cascade through the food system?
It can, if we just focus on groundwater for irrigation, which doesn't need to be the case, right? So we can utilize our surface irrigation. So, you know, sustainable harvesting of rainwater could potentially, in theory, you know, provide safe search. But we need to understand that it's the easiest thing that we try to do. So as a policymaker, or maybe even an elected official, it's much easier for me to promise boreholes or, you know, tube wells before an election and then do that. But then as a farmer, if I do get easy water right now without thinking of, you know, what's going to happen in 20 years, 30 years, that's what I will do. And that's why it's very important to bring science into long-term policymaking, because in terms of policymaking, we cannot just focus on how to make a safe and secure system right now or in 5 years, because we have to think about the future generations and we have to think about 20, 30 years out of it. And when I think of that, you know, the time to do anything was yesterday, right? We had to have a sustainable system of irrigation system in place to keep it going that way. I definitely do see a worsening trend, and I do see concerning trend. If we lose all our groundwater, what will happen? And we do believe, based on research, published research, that we might lose, you know, something along like half of it. Half of our winter crop might be gone if we lose that access to groundwater. But again, that doesn't need to be the way. There are ways to make our surface irrigation sustainable. There are clean energy that can support that. But then again, we need to make sure that we move away from providing subsidies for all the wrong reasons and provide it to support the right way, to do it in a sustainable way that would be sustainable, fair, and just for the longer time scale.
Very interesting. Thanks. That's encouraging that there are some potential pathways there. Well, we're at time, so thank you again. And we'll move on to our final speaker. Simon Jarvis is here, and he's the Director of Operations at FareShare Southwest, which is an independent charity collaborating with the UK's largest food charity, FareShare. And so as part of a nationwide network of 21 similar entities, FareShare Southwest combats food waste and hunger. And by acquiring surplus food from the supply chain, FareShare Southwest efficiently allocates it to over 400 charities, schools, and community groups throughout the Southwest, spanning, I'm gonna mess up my UK pronunciation, Gloucester to Penzance. You could tell me how I
okay.
Gloucester. All right. And in the 2021 to 2022 period, FareShare Southwest orchestrated the delivery of over 3 million meals, which is really quite impressive, aiding almost 50,000 vulnerable individuals across the region. So Simon's here today to talk about the work of FareShare Southwest, and we're really happy to have you here closing out the session. So take it away.
Lovely, thank you very much. And I wanted to start just with a thank you to IOP Publishing, partly for inviting me today, but also because we've been selected as their Charity of the Year for both fundraising and volunteering. So it kind of felt like the least I could do to come along and help support the event with a bit more information about what we do. So as Nathan mentioned, I look after operations. That means that I look after our food redistribution infrastructure, and I'll talk about that in a bit more detail through the slides. So who is FareShare Southwest? We are part of a UK network of 21 independent charities. We take quality in-date surplus food, which otherwise might go to waste, and we turn what could be an environmental problem into a social solution. We work with the food supply chain and dynamically receive large volumes of food. We have an army of volunteers who will sort through that food, check everything's okay. They will pick through the food to match up what we receive with what the different organizations we work with need and what they use. And then we use our fleet of vans to distribute this surplus food to a network of over 400 frontline organizations. Last year, FareShare Southwest supported 393 charities, schools and community groups. We helped them to redistribute over 1,470 tons of food, and that translates to food for 3.51 million meals. And looking at those numbers, we estimate that supported around 47,160 vulnerable individuals. So behind some of these straightforward stats for what we did last year, we received food from approximately 500 food companies in the last 12 months. The majority of those are national organizations, big name brands, manufacturers that everyone will be familiar with. We also invest very heavily in local food sourcing. So we work with over 50 local food producers, including Riverford Organics, St. Hugh's Eggs and Pie Minister Pies here in Bristol. We recognise that food companies don't want to throw away good food. People are kind of inherently against that, and they understand that it's good to try and get it to someone who can eat it. And so what we aim to do is to make it as easy as possible for companies to be able to send food to us and for us to be able to respond quickly and help them with that, and then to get it on to someone who can put it to good use. To make our operation work, we have over 280 regular volunteers. They are the lifeblood of our organisation. They drive our vans, they help pick the orders, and they do the delivery to the organisations that we support. We have a fleet of 13 chilled vans and one 7.5 ton truck. And this is the way that we get our food to where it's going. We don't just support charities, we also support schools, community groups, homeless shelters, breakfast clubs in areas of high deprivation, elderly lunch clubs, organisations supporting those in recovery. We also, wherever we can, we try to support organisations that do more than just provide food. It's commonly referred to as wraparound support. So they look to offer things like debt advice and signposting and support groups, so that the food help that they're providing is not just a sticking plaster, just getting through that meal that day. It's about helping someone to get back onto their feet and out of a perhaps vulnerable or uncertain situation, and to then be in a position where they can support themselves more easily. And we're particularly interested in trying to address the root of poverty and delivering an increased social value beyond just a food parcel. And there's that sort of companionship and the extra value services that come alongside the kind of organisations that we support. I'm now just going to play a short video with a bit of an overview of what we do and some words from our new CEO. So hopefully this will play smoothly.
Right now, 6 million tonnes of edible food go to waste in the UK each year. FareShare Southwest looked to take the problem of food waste and turn that into a social solution. What we do is to redistribute that food. FareShare Southwest work with farmers, supermarkets, small producers to save their food going to waste. There are a number of reasons why food might go to waste. It could be overproduction. It could be the fact that there's a change in the style of packaging. It's not just about short-dated food. There's a host of different reasons why food is potentially going to go to waste. From our warehouses in Bristol and Plymouth, we take that food and we redistribute it to food banks, community groups, breakfast clubs, schools from the west of England, Devon and Cornwall.
So it's given us a lifeline, really, and we always talk about being a lifeline to people needing food, and actually, FareShare are kind of a lifeline to us, which means that we can give good quality provision to the people that need our food parcels. If a family can plan for their meals and they know they've got food on the table for 3, 4, 5 days, it takes a lot of pressure off them. It alleviates the worry and the fuss that they go through.
So FareShare Southwest are very much dependent on its volunteers. They will drive the vans to deliver the food. They will pick and pack orders for those charities that we supply to. They are very much a key part of everything we do. And we need your help. There are 3 ways in which you can help. That's to volunteer, spread the word, and donate. And if you visit our website, you'll find more details of how you can get involved with FareShare Southwest.
So that was just a little bit of an introduction to us and what we do. As I mentioned, we're based in the southwest. So looking at this map, we're covering Cheltenham in the north, across to Chippenham in the east, and down to the bottom of Cornwall. So the sort of peninsula in the southwest of the UK. In the financial year 2019 to 20, we distributed food for just over 1 million meals, which was pretty impressive in itself. And then the pandemic came along, and that changed everything. We massively scaled up. We were selected by government organisation DEFRA to distribute food aid throughout the region. And in the following year, we distributed food for over 6 million meals. So if you can imagine what it's like for an organisation to increase its output 6-fold in the space of a year, that's quite a significant stretch. We set up an emergency food aid warehouse next to the football stadium in Bristol. And we also expanded our services into Devon and Cornwall for the first time that year. Here on the map, you can see the apple up to the north of the map is where I am here in Bristol. We also have a partner warehouse in Exeter, just around where this tomato is at the bottom, working with an organisation called Exeter Food Action. And then in 2022, we opened a warehouse in Plymouth, down here, the other apple to the south of the image. In 2021, we expanded what we were doing in Bristol and opened a second warehouse there as well. And since its launch in May 2022, our Plymouth warehouse has already got food for over 1 million meals distributed throughout Devon and Cornwall. And we're currently working on expanding our provision right down to the bottom of Cornwall with some local food hubs and opportunities for organisations to collect food from us there. So why surplus, and then why FareShare? So the food that we get can become surplus for many different reasons. It could be a case of weather conditions mean that there is a glut in a certain crop. It could be there's an issue with labelling, which is then not economically viable for a manufacturer to work through and relabel. We sometimes get things like missing ingredients in production, or a manufacturer runs a trial batch for a certain reason, and then they will have used that to test out and validate their equipment or their production process, and then the food that's made as a result can then be used by us. Could be very simple things, just like a printing error, colour in a logo, or something like the weather. In the UK, we have very changeable weather, and supermarkets may have predicted demand for barbecue food around a hot weekend, and then that weather doesn't materialise. So any of those things can impact the demand and generate surplus food for what we do. In the UK, over 270,000 tonnes of perfectly edible surplus food is thrown away each year. A vast majority of that food waste occurs in the supply chain. So everything we're talking about here is before it even reaches the supermarket. There's commonly the misconception that surplus food is just that sort of yellow sticker and coming up to its use by date and poor quality food. It's not that at all. What we deal with is large volume, in date, good quality food that is just surplus for one of the reasons I mentioned. Also in the manufacturing and production chain, the food is purposely overproduced to make sure there is sufficient supply. And the data that we're generating and working with manufacturers enables us to help them reduce that waste. A very neat example that we've got in the slide here, this jar of lasagna sauce. As you can see, someone put the labels into the machine the wrong way up. All of this came out labelled upside down. It just wouldn't make sense for the manufacturer to pay someone to go through and relabel all of that. That resulted in 891 kilograms of upside down labelled pasta sauce coming to us. We're then able to redistribute that to 110 different organisations throughout the region, and for that to be eaten and put to good use. Next part of this is then why FareShare? Why are we the people to help distribute this food? mentioned at the top, we're part of the FareShare UK network. There's no organisation that operates at the scale that we do that can deal with the quantity of food that we distribute throughout the country. Each of the warehouses I look after in the Southwest handles around 10 tonnes of food every week. We're not a food bank. We're taking that food and then we are enabling other organisations. So we don't give directly to individuals. It will go on to organisations that can then put that food to good use. We're also able to handle a whole variety of food. We can handle very quickly fresh, chilled, ambient food with short shelf life where we need to be reactive and respond quickly to offers of food. And literally today we've just turned on our freezer that we've newly built, and very soon we'll be handling frozen food as well. We've got good relationships with all of the major food companies, supermarkets throughout the country. And we also work with smaller regional food producers and look to bring more of them on as time goes on. I'd like to talk a little about the food waste hierarchy. Hopefully some of you will be familiar with this already. As you can see, the top step on food waste is about prevention and is working to ensure that food doesn't become surplus for any reason and all raw materials are used in production and there's no overproduction. But the next best step when that has been made is redistribution to people. And so that's where we come in. So second only to preventing that waste in the first place is what we do, and is coming in and getting that food and getting it out to someone that's going to be able to eat it and put it on a plate. We very occasionally do a small amount of the next one, and we work with a few organisations that have livestock, and occasionally it is food that we struggle to move through our normal routes that can then go on to animal feed. Beyond that, everything in the bottom half, the yellow, orange, red of this diagram is then food waste rather than surplus. And that means it's not being eaten, it's not being used as food, and is being put through other processes. A real challenge for us at the moment is that yellow block there is currently very heavily subsidised in the UK. And so it often makes sense for growers in particular to either send food waste to anaerobic digestion or to plough it back into fields. And there are subsidies to support those things. And so that's something that our parent charity FareShare UK is actively campaigning to try and reduce what's going on there, because it's counterproductive and is meaning that food is not making it to people when it could otherwise. The next thing I'd like to talk through is a few examples of the ways that different suppliers support us and how surplus food that is arising in their manufacturing is being put to good use. So first example is an online butchers and grocers called Field and Flour and their Leg Up campaign. This is a particular one that runs around Christmas in the UK. Roughly 10 million turkeys are sold at Christmas in the UK, and around 70% of those, 7 million turkeys, are sold as turkey crowns without the legs. And that results in, as you can imagine, if you work through the maths, 14 million surplus turkey legs are then generated as a result, which is around 7,000 tonnes of meat that is just not wanted, not in high demand from consumers. So last year, Field and Flour did a special campaign focusing specifically at Christmas and this imbalance in demand between the turkey breast meat and the turkey legs. And they sold 770 pairs of turkey legs and donated a further 250 pairs to us. That meant we were able to feed around 1,000 people on Christmas Day across the southwest of England, and distributing that out to be on the Christmas table. This year, they're expecting to scale up what they've done versus last year. And they're hoping to donate over 550 turkey legs to us. And so it's a really neat example where you can quite easily see the tie-in between the in-demand cuts of meat, the less demand, and the way that this manufacturer, this producer has worked to make sure that's not going to waste. The next one I'm going to talk about is an organisation called Riverford Organic. Riverford are a sort of conglomerate of grocers working with farmers, again, here in the southwest. This year, the weather meant that they had they describe as a mountain of leafy brassicas, which were at risk of being wasted. The weather, bizarrely warm autumn that we had, combined with sales not being quite where they expected, meant that their normal veg boxes they deliver weren't quite planned as they expected. And they've sent us quite an interesting breakdown of the economics behind this. And they've said for every pound they pay a farmer, it costs around 30 pence to plant, weed and tend the crop. It's about 30 pence goes into the overheads to make the farm run, so diesel, machinery, insurance, everything like that. It's 30p to then harvest and to physically get the produce out of the ground. And then 10p is left to reinvest or occasionally to make a profit. if Riverford are able to find the sort of 30 or 40p they need to pay for the harvest and send a little towards the grower, then they can work to gather that crop that might otherwise be wasted, get it to us, and then we can move it on to families, schools, and other organisations helping those in need. So what they did was they created a special fund, and they contacted all their customers and said, this is what we're trying to do, and asked them to chip into it. They worked with us and some of the funding sources that we've got, including an organisation called the Big Give Christmas Challenge, and pulling all that funding together, that meant we were able to work with them to recover 10 tonnes of fresh veg, which otherwise would have either gone to landfill or just been ploughed back into a field. Those 10 tonnes went to over 210 charities, community groups in the southwest. Surplus even went beyond the level that we were able to move through our network. So some of that went back into the FareShare UK national network. And some of those vegetables went as far north as Yorkshire, going to organisations right up to the other end of the country. And this particularly high value surplus because it's very nutritious vegetables, kind of thing that are hard for people to get hold of otherwise. And it meant that those organisations had a great variety of really exciting, interesting crops. And then since this campaign, the success of the Save the Happiness campaign, as they've called it, they've then set up a fund where anyone who signs up as a customer and refers a friend of theirs, Riverford, as an incentive for people to make those referrals, will then donate into this fund, and they use that to be able to help get crops that might otherwise be going to waste to work their way to us. The next one I've got is from an organisation called Yo Valley, who put together their Left Yovers project. It's probably worth pointing out that not all of these projects have to have a punny name, but quite a few of the ones that I've got here just have, because it makes it a bit easier to talk about and makes it easy to communicate with their customers as well. So the Left Yovers project from Yo Valley, they're a large dairy and particularly kind of cream and yoghurt producer. Earlier this year, they realised that something that was happening in their production was that occasional cases, maybe 1 or 2 pots in a case of 6 or 12 might be damaged. And that meant that obviously the damaged pot was no good, but the rest of that case wouldn't be accepted by their customer, by the supermarket. So they thought, look, how can we get these yogurts, these pots of cream on to be put to good use? One of the big challenges from them was about how they logged this stock, because they might be producing for one supermarket and then switch over to another one and different flavors, and none of that would be enough to form a whole pallet, but they still wanted to be able to track that so they could meet the legal requirements around traceability for food. So they had to do a bit of brainstorming there. But working with us as well, they were able to solve that and put a process in place for logging that stock. And then thanks to that, they're then able to get 1 or 2 pallets of stock that make their way to us each week. And then the last example is a project called FareShare Flex. This is where about 30 tonnes of sun-dried tomatoes were offered to us, getting pretty close to their use-by date. In that form, it was very hard for us to be able to shift them within the time period that we had and to work that through our network. So some of our colleagues at FareShare UK worked with the company offering this and another partner to launch this FareShare Flex project, where they turned the sun-dried tomatoes into some tinned ambient sun-dried tomato soup. So it's a really rich soup with paprika, herbs, and really strong flavour that then once tinned has a 3-year shelf life. So from that project, all the soup came back into the UK network. Within the southwest, 3 tonnes of that came to us. We were then able to pass that on to 202 different charities, knowing that this sort of 30 tonnes that nearly went to waste all got turned into a high value and an easy to use product that then got distributed from up to Gloucestershire all the way down to Devon, to schools and homeless shelters that we work with. Another avenue that we use to help get food that might otherwise be going to waste is the Surplus with Purpose Fund. A huge area where surplus is generated in the system, as mentioned in some of the earlier talks, is at the farm level. It's estimated that around 25% of the national food waste in the UK happens before it even leaves the farm gate. The weather, buyer patterns, things like that can have a huge impact of what proportion of crop a farmer can sell when their crops are being harvested. They also will often plan overcrop, maybe up to 10% or so, that they know they're not going to sell, to make sure they can guaranteed to fulfill their orders. The fine margins that exist in farming mean that it often doesn't make economical sense for them to pick and package that overstock and to get it to someone like us. So the Surplus for Purpose Fund is administered by FareShare UK and is used to help producers to offset those costs and to help fund either labour to go out and pick or to pack and get food to us, so that the healthy food can get to people in need rather than being ploughed back into the ground. The World Wildlife Foundation and Tesco did a report last year, and they estimate that 2.9 million tonnes of the food that goes to waste on UK farms each year is still edible. In our estimation and the analysis that we've done, that's enough for 7 billion meals of food. And the amount that's wasted in the primary production in the UK before it leaves the farm or the fishery is higher than has previously been calculated, and accounts for over a quarter of the UK's total 12.9 million tonnes of food waste each year. So FareShare UK is calling on the government in the UK to commit £25 million annually to deliver the equivalent of 1.3 billion meals worth of food. This, going back to the previous slide, is to follow up the Surplus with Purpose trial project that ran, initially funded by DEFRA, a government agency, but then has been stopped and now no longer helps to meet those needs, and that funding's just been sort of allocated elsewhere. It's not quite clear where that funding's gone, but isn't available to this use. And so it means that this food is just going to waste on farms when otherwise we could tap into it. Food waste from this survey as well. Food waste accounts for up to 10% of all global carbon emissions. The amount that is generated is more than 4 times the amount of carbon dioxide produced by the world's entire aviation industry each year. So we're talking huge scale of potential environmental impact as well. In the UK, food production and the waste that's associated with that creates 35% of the total greenhouse gas emissions. And a quarter of the food grown in the UK is never eaten, so it's hugely wasteful. Putting all of that waste then into context, I'd like to talk a bit more about the kind of the need for what we do from a social and a people perspective. So the Food Foundation have conducted some research, and we've got some data showing here running up to June 2023, showing that in the UK, a total of 13 million people, 9 million adults, as you can see in the graph, and approximately 4 million children experienced food insecurity in June this year. This is just under 20% of the UK population, or 1 in 5 people. And as you can see by the graph as well, the pandemic has made this much worse, and the number of people affected by food insecurity has roughly doubled since the start of the pandemic. Taking that demand further, this situation has been worsening for households with children in particular. 1 in 4 households with children experienced food insecurity in June 2023. And as of February 2023, over 3/4 of food insecure households with children were worried about the impact of food insecurity on their children's mental and physical health. Nearly 70% of households in the UK are extremely or very worried about food and drink inflation. Bringing this really close to home for me particularly, and us here in Bristol, 36.1% of children in Bristol Northwest, and 32.1% in Bristol South live in poverty. The national average in the UK is 27%, so we're unfortunately slightly above that in some major areas of the city. The other factor that's driving this very strongly is inflation is unequal. The inflation data for the UK for the year to August 2023, general inflation was running at about 6.7%, but food and drink inflation almost double that, 13.6%, and that's really hitting families very hard. The Resolution Foundation here in the UK did some research, and they summed up their research saying that typical working age household incomes are on course to be 4% lower in 2024 to 2025 than they were in 2019 to 2020. Never in living memory has families got so much poorer over the course of a parliament. In terms of what we're doing, we are just about to relaunch our winter food operation for this year. Our winter food operation is called Food Stock. And we run a campaign with a big focus around winter, particularly because that's a time when schools break up and children don't receive the free school meals that they might otherwise during the school term. And also the weather means that people then have greatly increased fuel bills and needing to heat their homes. What are we going to be doing? We're reopening our emergency warehouse at the Ashton Gate Stadium. We're upscaling operations for our existing warehouses. Last year, in the 2022-23 food stock, we had over 190 corporate volunteers in 2 weeks who helped to pick and pack food parcels. We delivered 1,700 festive food and activity parcels to families across Bristol, 234 tonnes of food to nearly 40,000 people. We also supported our friends at Caring Bristol to serve up Bristol's big Christmas dinner for people experiencing homelessness, delivered more than 5 tonnes of food just to them. And we also kept thousands of people across the southwest from going hungry. I've got a short animation now just showing what we do in our food stock campaign. Sorry, I'm not sure I jumped forward.
Right now, more than 10 million people in the UK don't have enough to eat. Going hungry affects our children's life chances. It threatens our physical and mental health, making us more likely to become ill or isolated. As the region's biggest food charity, FareShare Southwest is a lifeline for tens of thousands of people. Every week, our volunteers deliver good quality, surplus food to hundreds of frontline charities. This year, the need is greater than ever. With your support, we'll deliver food for 1 million meals, pack thousands of food parcels, and work with other organisations to get food to families who need it. This Christmas, you can stop people from going hungry. Donate, spread the word, volunteer. Thank you.
So our food stock campaign that we run over winter is completely powered by corporate volunteers sorting, donating stock and packing food parcels. And it's a great way for companies to get together with their team and really make the most of company volunteering programs. Moving on to what's next for us. In the next year, we're going to be looking at maintaining all 3 of our permanent warehouses and delivering food for around 60,000 meals each week. We are currently bottlenecked by the amount of surplus food that we can get hold of, so we're working to increase that, particularly in our local area. We continue to develop our volunteer program and employability program, helping young people to get into employment. And we're also delivering targeted regional programs across the southwest to help tackle food poverty. In terms of what support we always need donations, financial donations to help increase our impact. We need food, as I mentioned, that's the thing that's sort of holding back the amount of growth we can have. Pro bono support from companies offering their team or their time to help our budget stretch further. And we always need volunteers, regular volunteers to run our operation and support our holiday operations. We also really value engagement. So that's one of the easiest things that particularly international audience can help with. Liking our posts on social media, following our various different accounts and sharing the work that we do really helps to maximize our reach and our impact. We've calculated from our work that every pound that's raised by us, we can get food for 4 meals to someone in need. I think we're running a little bit close to the end of time, so I've got a few slides just with some quotes with impact. I'll just whiz over those ones, and then wrapping up just to say thank you for everyone for joining today and for giving me the time to talk about this. And hopefully we can cover off a few questions now before the end of the session.
Thank you so much, Simon, for sharing all the excellent work that FareShare UK Southwest is doing in the UK. Yeah, just a few questions for you. Camille asks whether companies giving food as charity, do they receive incentives to do so, like a tax cut, and whether there's any conversations about national systems or enshrining some benefits in law, and there's a reference to a recent French law surrounding this. So I'm wondering if you could just speak to that.
Yeah, the most simple way is that obviously stock that goes to waste can be written off against tax. So if you're not selling it, you're not making profit. What we also do, we're often taking product from companies that would otherwise have to pay for that to go to waste. So we provide a service to food manufacturers, and the supermarkets, big supermarkets in the UK do reflect that with the fact they tend to donate money as well. And it's part of their sort of corporate social responsibility and their ESG policies, showing that they're not just sort of using us to solve a problem of overproduction or contracts with their suppliers being unfair and skewed in their favour. So they do support our work and help there as well. The French law is a very interesting one, and I don't know the exact specifics, but I'm aware it's along the lines of mandating food that is surplus to be given to food banks or other organisations, and making sure things like putting good food into a bin and pouring bleach over it to stop homeless people coming and helping themselves, things like that don't happen. And we are actively campaigning, and particularly FareShare UK, our parent organisation, have a much bigger role in lobbying government and trying to bring things like that about to make sure the legislation is there to prevent this waste before it happens, and make sure that companies are thinking about it. And then coming back to what I mentioned about ensuring that we don't have the perverse incentives of tax cuts for anaerobic digestion, and companies think they can get a subsidy there when actually it would be better for everyone as a whole for that food to go and be eaten instead.
Yeah, thanks. So another question for you. What are the main barriers for companies to donate surplus food to FareShare Southwest?
I guess that the first part of that is about just identifying it in the first place and looking through production. So in the field and flour example I gave, it was quite clear to them that the turkey legs are going spare. With Yo Valley, it took a bit more for their team to speak up and realize, well, hang on, we've got 4 or 5 pots out of a set of 6 that are going to waste, and we'd like to do something good with that. And that's something that's come about through great leadership at that company, involvement of our team with their team, and getting all of their factory operatives thinking about looking around them in their day-to-day and thinking, could we do something better with that? Why is that's something that someone could eat? Why is that going in a bin pile rather than moving on elsewhere? Another challenge is just awareness of us, getting our word out there. Some food manufacturers don't know that we exist, and there is this kind of opportunity for them. There are also practical logistical hurdles around labelling, tracking that stock, getting enough labour to repackage, label up, and make that stock into a state that it's suitable for us to receive. Sometimes there are challenges on our side of being able to collect that within the timescale. Food is by its nature perishable, so as soon as it's picked or packaged or something, that clock is running, and some you've got a longer time than others, but still we need to be able to move fast. And then also sometimes it's timing as well. A company may come to us and say, we've got this volume, but we need you to take it now. And if that is 30 tons of sun-dried tomatoes, then maybe that's a bit too much for our network at once. And we do have cases where we'll be overwhelmed by pumpkins in pumpkin season, and the organizations we work with will say, hang on a minute, all of the people we support have got pumpkins. We've got too much, we can't shift them anymore. And we do what we can to try and balance up the stock that we get in with the need of our recipients, but that doesn't always work, and there can be an imbalance. But what we are concentrating on doing is trying to be able to say yes to the food supply chain whenever we can, and to be that one-stop shop for them to think, we've got some surplus, where can we send it? FareShare.
Awesome. Thanks. Really inspirational work that you're doing. And I want to say thanks again, and thank you again to all of our speakers, John Ingram, Marta Tuninetti, Navin Ramankutty, Pinki Mondal, and Simon for being here today and sharing about their work on food system solutions, from production all the way to consumption, and addressing the supply chain in the middle there. So really inspirational talks, and thanks also to IOPP for organizing this event. I believe the next day, or the next event, will be on Wednesday. So thanks again, and have a great rest of your day.
Thank you.